Hello everyone. Specific type and then assign some value to that, right? Right. We use here we are defining a variable name which is a, which is containing a value 5 and its data type is integer, right? But if I want to store the values of 60 variable, 6000 variable, 6 lakhs variable, the traditional process is you will add that much count of variables and assign the values to them. But this process for the long data type you cannot do that, right? What you will do, you will use such data type which you can easily use to store the values of that data. What we will do, we will create similarly we will create the array of any name and assign the values to that. The benefit is that in the memory, at this consecutive memory locations, your data item is stored, right? Like, see how we declare an array is the process of declaring arrays. Right here, what it is showing that we have declared an array of integer type and its name. Basically, A is what? A is the name of array, and what is 50? 50 is the consecutive memory locations which we are talking about. We can access the that locations to store the data. And about array is in array random access memory consecutive 650 memory blocks of any memory location will be assigned to this particular data variables. Moving toward next. See, what is the length of array, how array is represented? Starting from the, if I am assigning an array of size 10, let's suppose A is of size 10. That means it ranges from 0 to n minus 1. That is 0 to 9. In normal process, we can initialize it as 1 to 10, right? So, during processing, we need to consider if we have initialized within 1 or 0, right? So, this is the process. Now, how I will find out the length of it? Firstly, with this size, we can identify what is the length of array, what consecutive memory locations it can occupy, and other than that, there is a method like length equals to ub minus lb plus 1. Now, what is ub? What is lb? Right? See, array is represented like this. these are the data items we have stored in the array, and we are representing the index value like 0, 1, 2, 3, 4, 5. We are having an array of size 10. Now, LB is the first location. First location like this very first location, which is containing the specific data value. And what about UB? UB is the upper bound. Upper bound means the last higher indexed value which contains some data item, which is 5. This is your UB. And what about the 9? Let's suppose we are proceeding from 0 to 9, which is representing 10 data items. So 9 is what? 9 is the maximum number of array. Max is what? Total number of items in the array. So upper bound, which is maximum value, which is highly occupied space 50 plus 1, it defines the size of that array, right? See, we can represent the elements of arrays like A1, A2, A3, An, and it can be represented in the subscript form also. Next, we have the representation of array in the memory. Array can be represented in the, this is the numbers we are using for our understanding to store the array data type. But actually in the main memory, the memory locations are represented in the hexadecimal format. So this number is for only understanding. See, if we are defining the array of any size, we are saying it contains the homogeneous data type. If we are defining int array, float array, character array, it contains the values of that data type, right? So if I am assigning the data type any type of array, like one integer variable occupies 4 bytes. So for any number of data items which we are defining in the array, it will contain the 4 means size of array into that data type, size of that data type, that memory location. Let's suppose we are storing 10 elements in the array and we are saying it is of integer type. Then it contains total 40 bytes of memory to represent the array memory location. Let's suppose these are the memory segments which we are defining to store the array. See now, from this location, let's suppose I am having some elements in this segment corresponding to this address. Now, how we will find out the address of any specific location from the given location? Let's suppose I want to find the address of second item, third item, fourth item, fifth item. That we can find out easily based upon the base value. Base value is the initial address which is already given to us, like 1000, and this is the base address of this array. So what we will do, we have this formula to calculate the value of base address. Like if I want to add 2, 3, 4 any specific location's address, we will follow this and we will come to the conclusion or answer like this. If we want to find the address of location 6, location 6 is this. So what our formula says, it says base address, which is 200 base address value plus W. W is what? W is the size of that data type. Suppose it is given in the question, it is 1 byte. So it will contain 1 byte, and then K. K is what? That specific location. And what about 1? It is the lower index, lower bound value, which is the lower bound. So after computing this, we will come to the conclusion that element 6 index value having index value 6 is stored at the 205 memory location, right? Next we have some operations on data structures. See, we have different type of operations on data structures like creating, insertion, searching, sorting, merging, deletion. See, based on the category of data structure we are using, we will follow that operation. Like for stack, we will perform push and pop. For arrays, we perform traversing, insertion, deletion, searching, sorting, merging. Right? So depending upon the type of data structure which we are using, we perform the specific operation. For arrays, today we will discuss traversing and insertion. If we will cover deletion, that will be the best. Right. Starting from there, see what is traversing. Traversing means assessing each and every element of array from the starting location till its upper bound value. That means if my array is of size 10 and it is containing 5 elements or 4 elements, what we will do, we will traverse, visit. Traversing means at least visit all the member of elements at least one. Let's suppose we are having some data item at this position. What we will do? We will starting from using this, like starting from the index value, that is lower bound which is 0, starting from this index. What we will do? We will move toward the one location next in the case of traversal, right? Like this. So up to the upper bound value, we will traverse each and every element of the array. We can print its value. We can perform many operations after traversal, like printing, reversing, duplicating. For any operation you are performing on array, you have to at least traverse the array for one time. Right? Next we have insertion. See, for insertion and deletion, that are the basic operations on any data structure. For insertion, there are 3 operations specific. That is insertion at the midway, insertion at the middle, and insertion at the end. And likewise, we have deletion. And for deletion, we will also follow the same method. Deletion at the end, deletion at the starting position, and deletion at the middle. Middle means we are deleting the element from any specific location. It is not restricted to centered element only. We can also perform the deletion or insertion in sorted and unsorted list. That is basically the position value which is given to us. Like if we start insertion, if we start with insertion. If we are having an array of, let's suppose we are having an array and we want to insert some data item. See, before insertion, I will let you know that before insertion and deletion in any data structure, first we will always check overflow and underflow condition. What is overflow condition? Overflow condition is just to check that our insertion process does not exceed the capacity of that data structure. Let's suppose I am having the size of array 5 and I want to add and that array is occupied already and I want to add some more items, right? I have 5 elements and I want to perform insertion in this case. What will happen? Can we insert the value in this kind of array? Firstly, we'll check overflow condition. Overflow condition is if UP is equal to max. Right? What is UP? UP is the higher occupied index value, like as I earlier discussed. And what is the max? Max is the size of array. Here max is what? 4, and in this case 4 is representing to the UP also. If we try to insert the data at the end or any specific location, we will lose the earlier data. We can overwrite the data, but we cannot add data at newer location, right? So if this case occurs, in case of insertion, we will simply say we cannot insert the data at any location because it's an overflow condition. If there is some space in the data structure, what you will do, you will firstly check overflow condition, and if there is space, add the elements at any location. Like if you want to add the elements in an array at the end location. So what is the process? See, this is representing the lower bound and this is representing the upper bound. Right? What we will do, we will check the max size. Max size is here something like 8. So we are having spare locations where we can add data or we can perform insertions. So UB is not equivalent to max, we can insert easily. And for insertion at the end position, it is very simple process. Like what we will do, we will add the data at the 1 plus index width. If I am having upper bound and fourth location, what we will do, we will upgrade the value of UB is equal to UB plus 1 and add the data item to that upgraded UB. Now, after doing UB is equal to UB plus 1, now my new UB will represent to the next memory location which I assigned this time. Right? So, we can add data at new UB. And let's suppose I want to add 60, I will directly add 60 to this particular location. Right? Now, let's suppose this is the process of insertion at the end. Now, let's suppose if I want to add the element at the beginning of the array, what we will do? Can we directly add the value to the first location? See, if we will directly add the value to the lower bound, what will happen? This value will be overwritten with the newer one. So we don't want to lose our data. What we will do? We will simply shift the entire array. If you want to retain your data, you will simply shift the entire array by 1 plus location. Like what we will do for insertion at the beginning, we will shift this value. This is the upper bound at the moment. What we will do, we will shift this upper bound value to the UB plus 1. That means UB plus 1 will contain UB value. Right? Every value is moved toward the 1 plus location. And what about the counter variable? A variable which backtrack the index value that will decrement by 1 and value is shifted by 1. Likewise, we will shift the value of 60 to the new location and at the value of 60, we will override it with the previous value. And similar process will go on the all other data members in the array data structure. Well, we will decrement the variable by 1 and if we reach that variable reach at the lower bound value, that is representing the 0th location. That means we are having the entire array shifted to 1 plus location and the 0 index value with the same value which is present at the first location. So if we override at this location, then we cannot easily override because we are adding at the first location, right? So we are maintaining the previous value as well and we are adding the newer one also, right? Likewise, if we want to add the data at the specific location or we can say middle of the array, what we will do? Like in starting position, we traverse the array in backward direction till lower bound. But what if we want to add some data at the specific location? What we will do? We will, let's suppose I want to add the data at the position number 3. There is a difference between position 3 and index value 3. To make it very clear, if I am talking about the index value 3, that means I am pointing to the 40th location. And if I am saying position 3, that means position 3 is representing to the array index 2. Right? So what we will do? We will start moving data to 1 plus location. We will follow the process up to when we reach at the position, given position. What we will do at that moment, we will check. We are at a given position. We will add the element. We will shift the data to what? Given position data. At the moment I will reach at 3 or 2 or which is whatever the given position is, I will make the copy of the data. Copy means I will overwrite the newer data with the specific position. Right? Like this. If I want to insert the 4 at the last position, I will simply add index value is upgraded by 1 and we will add 4 to the next location. If I want to add any number at the given any name or number, whatever we are using data at any specific location, what we are doing, we are shifting that value to one place down and we are adding that data item to that specific location. Right? Likewise, insertion is performed, deletion is the reverse of that. We will perform the deletion at the end location, at the beginning location and at any specific location. You can also perform deletion in the sorted and unsorted data structure array. See what we will do in case of deletion. In case of deletion, like this. If I want to add delete the value from the index value 7, what we will do, we will simply upgrade the upper bound value. See, in the case of array, LB and UB plays a very important role. So make it very clear what is the LB, what is UB. So in this case, 7 is our UB. What we will do, what we are presenting up to this place. That means if 7 is containing some item at the moment, until we overwrite the value at 7th place with a newer one, it will contain that same value, right? So what we will do, we will upgrade the value of UB to UB minus 1. Like we have performed in insertion, UB is equal to UB plus 1. In case of deletion, it will be UB is equal to UB minus 1. And from specific location, let's suppose if we want to delete the element from this particular location. In the case of insertion, we are shifting array toward the upper bound, but in case of deletion, we will shift our entire array towards the lower bound. Right? We will shift the value of this. We want to delete the value of this element. What we will do? We will shift entire array to one place down, one place up. Sorry. Likewise, if we want to delete the element from any specific location, up to that specific location, we will make changes and up to that specific location, we will perform changes and rest will remain same. So, insertion and deletions are the basic operations which we perform on any data structures. Other than that, you can perform searching, sorting, merging on any data structure. So, these are the algorithm to represent the insertion process at any specific location, and this is the process for deletion of element at any specific location. We will discuss rest in next video. Thank you.